Hello, my dear students. Match the following. Ether ROR form. Alkyl groups are same. So this is considered as symmetrical ether. A1. With A1 only one option is there luckily. So third option correct. Alkyl halide reacts with sodium alkoxide. Then it gives Williamson ether synthesis. Benzene reacts with SL halide. Friedel-Crafts acylation. Based on Bohr's theory, when n value increases, choose the incorrect statement. Velocity of electrons increases. No. Why? Because the relation between velocity and orbit is inversely proportional. Incorrect statement this is. Total energy of electrons increases. N value increases, total energy of the electrons increases. Yes, this is correct only. Total energy increases because here energy minus 13.6 minus negative sign is there. That's the reason that statement correct. Radial distance between two successive orbits increases. Radial distance directly, that means radius of nth orbit 0.529 into n square by z square. So radial distance is decreases. The relation is directly proportional relation. So this is incorrect statement. Energy difference between two successive orbits decreases. Energy of first orbit minus 13.6. Energy of second orbit is minus 3.4. Energy of third orbit is minus 1.5. Now find out the difference. Yes, decreases. Energy difference decreases. So incorrect statements A and C are incorrect. The magnitude of product of wavelength and velocity. Product of wavelength and velocity. Lambda into V value is given. How much it is given? 12.57. The product of uncertainty in velocity and uncertainty in position, how much would be? We know that lambda is equals to h by mv. Lambda into v is equals to h by m. So here h by m is present. H by m place substitute lambda into v. So delta x into delta v is equals to lambda into v by 4 pi. Lambda into v value 12.57 divides with 4 into pi value 3.14. 4 3 is 12. So nearly 1 time. Fourth option is correct. The given graph shows the variation of potential energy for a reaction using a catalyst and for the same reaction without catalyst. Which of the following is a correct conclusion? Which of the following is correct conclusion? Okay, this is the original graph in NCERT textbook. Delta H in the presence of a catalyst Z. Yes, delta H in the presence of a catalyst. Activation energy in the presence of catalyst is Y plus Z in the presence of. Correct. Statement 1 is correct. Which of the following process do not involve absorption of energy? Generally what we know, electron affinity 1, first electron affinity is exothermic. Electron affinity 2 is endothermic. Electron affinity 1, energy released. Electron affinity 1, energy required. So electron affinity 1 is exothermic. In case of beryllium, nitrogen, beryllium, nitrogen. EA1 is endothermic because of its stable electronic configuration. stable electron stable electronic configuration. You can check it. This is EA2 process. EA2 process, between negative charges repulsions are present, so it is endothermic process. Endothermic process. This is exothermic, exothermic, exothermic. That means A, C, D are exothermic. First option is correct. Assertion: xenon in XeF2 is D2sp3. This is the XeF2 structure. In XeF2 structure, 2 sigma bonds and 3 lone pairs are involved. Geometry is linear geometry and its hybridization is sp3d hybridization. But here given D2sp3, so this is wrong. Central atom in XeF2 molecule follows octet rule. XeF2 molecule, xenon group number 8, fluorine, valency 1, total fluorines 2. 8 plus 2 is equals to 10. Total number of electrons 10 electrons, more than octet. Both A and R are false. Match the following: alkaline solution of copper sulfate and sodium citrate. This is called Benedict's solution. Neutral FeCl3 solution, alkaline chloroform solution. Alkaline chloroform solution means this is nothing but CHCl3 plus KOH. CHCl3 plus KOH, it is used to identify one-degree amines. Carbyl amine test, CAT, carbyl amine test. Sodium hypoiodate. Sodium hypoiodate formula is Na. Sodium hypoiodate formula is NaOI. NaOI, it is used in iodoform test. Iodoform test. Now based on this, identify the correct answer. Benedict solution. Benedict solution is used to, which gives positive Benedict test, aliphatic aldehydes. Aliphatic aldehydes. So A3. So neglect second option, third option. A3. After that, neutral FeCl3 solution, which gives neutral FeCl3 test. Phenols, phenolic group gives neutral FeCl3 test. B4. After that, chloroform, it can be carbyl amine test. C2. Based on that, fourth option correct. Lattice energies of Kf, KCl, KBr and Ki follow the order. We know that lattice energy is directly proportional to charge and inversely proportional to radius of cation and anion. All the cases cation remains same, anions are different, F minus, Cl minus, Br minus, I minus. Lattice energy is inversely proportional to radius. So first option is correct. Identify X, Y, Z in the above reaction. Okay. First, solid form of AB is converted to aqueous form. Solid form is converted to aqueous form. That is considered as enthalpy of solution. So X is enthalpy of solution. Y, solid form of AB converted to gaseous ions. Gaseous ions. So that is considered as lattice energy. Next, gaseous ions are converted to aqueous form. That is considered as hydration energy. Based on this second option, you can check. This is the Born-Haber cycle concept. Born-Haber cycle concept is there in thermodynamic lesson. Thermodynamics. How many of the following are primary amines? 1 degree amine NH2, 2 degree amine NH, 3 degree amine. It can be represented like this. So tertiary butylamine, it is a 1 degree amine. Secondary butylamine, 1 degree amine. Isobutylamine, 1 degree amine. Dimethylamine, 2 degree amine. How many of the following are primary amines? 3 primary amines. Consider the reaction given Kc value is given. Kc value is equals to 278 and concentration is also given 0.01. It can be written as 10 power minus 3. Sorry. Oh. Number of moles are given. So number of moles is equals to 0.001. Concentration is equals to number of moles by volume. 0.001 by how many liters? 1 liter. So 10 power minus 3 concentration. Determine the reaction coefficient of the system and direction of the equilibrium system. So calculate first of all QC. Given equation is 2 moles of SO2 plus O2 gives rise to 2 moles of SO3. QC is equals to SO3 whole square by SO2 whole square into O2. SO3 whole square value is 10 power minus 3 whole square by 10 power minus 3 whole square into 10 power minus 3. 1 by 10 power minus 3, the value is 1000. QC value is equals to 1000. Kc value is 278. Based on this, QC is greater than Kc. QC is greater than Kc. QC value 1000. So remove third and fourth option. QC greater than Kc. So equilibrium shift to the reactant side. Net reaction goes from right to left. Right to left. This direction. Right to left. So equilibrium shift to the reactant side. When equal volumes dash and dash are mixed, the precipitation of AgCl. Okay, Ksp value is given. Ksp value is equals to 1.8 into 10 power minus 10. When PPT is obtained, QSP is greater than KSP, then PPT is occurs. Calculate QSP value. Take the first option. 10 power minus 4 into 10 power minus 4. 10 power minus 4 into 10 power minus 4 is 10 power minus 8. The value of 10 power minus 8 is greater than 1.8 into 10 power minus 10. So no doubt, first option is correct option. PPT is occurs. Which of the following gives a suffocating gas? Suffocating gas when treated with dilute HCl. Carbonate. Suppose carbonate is treated with dilute HCl. Then it liberates carbon dioxide gas. Carbon dioxide gas is colorless and odorless. Next, sulfite. Sulfite is SO3 2 minus. Reacts with a HCl. Then it liberates sulfur dioxide gas. Sulfur dioxide gas is suffocating and pungent odor. Sulfate. Suppose sulfate reacts with a HCl. No reaction takes place. Borate. Borate reacts with HCl. Then it gives boric acid H3BO3. No gas is evolved. Second option correct. The correct order of melting points of 3A group elements. Melting point order, yes. Boron highest. Boron after aluminium. Aluminium after thallium. Thallium after indium. Indium after gallium. Boron, aluminium, thallium, indium, gallium. The maximum covalency exhibited by carbon, we know that carbon covalency is equals to 4. And silicon maximum covalency is 6. 4, 6. OH bond polarity is maximum in. OH bond polarity is maximum in second option. Here, polarity of OH bond inversely proportional to plus I groups. Inversely proportional to plus I groups. Now you can check it. OH group attached carbon adjacent no other carbon, no other alkyl group. So 0 plus I groups. Okay. OH group attached carbon. Next 3 alkyl groups are present. So 3 plus I groups are present. OH group attached carbon adjacent 2 carbon atoms. 2 plus I groups are present. OH group attached carbon adjacent 1 carbon. 1 plus I group is present. What I discussed with you, polarity of OH bond is inversely proportional to plus I groups. 0.5 grams of organic compound. Weight of organic compound is 0.5 grams. 14 by 1000. In Geldal's method percentage of nitrogen is calculated by using this formula. Normality, yes, normality of acid is given as 0.1 and volume is given as 60 into 100. Now simplify 0, 0, 0, 0, 0, 0 cancel. Now 14 into 6 by 5. Simplify, you will get 16.8%. Benzene and nitration gives nitrobenzene in presence of HNO3 and H2SO4 mixer where HNO3 acts as a base and H2SO4 is acts as acid. Which one of the following fluorides does not exist? Which of the following fluorides does not exist? Nitrogen, NF5. NF5 not possible. Why? Due to absence of d orbitals. Identify X in the following reaction. N-alkane reacts with anhydrous AlCl3, HCl, heat. The process is called as isomerization process. Then it gives branched chain alkanes. An alkane on ozonolysis yields CHO, CH2, 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 CHO. The alkane is. Once you can check it, this is CH2 group, this is CH2 group, this is CH2 group. Correct? So this alkene undergoes ozonolysis. Ozonolysis break the double bond. Here CH is present, here CH is present. Ozonolysis, reductive ozonolysis, break the double bond, left side oxygen, right side oxygen. Then it gives CHO, CH2, 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 CHO. An organic compound A of molecular formula C6H12O2 was hydrolyzed with dilute H2SO4 to give carboxylic acid and an alcohol. C gives turbidity immediately. C gives turbidity immediately. That means C is considered as a 3-degree alcohol. Okay. When treated with anhydrous ZnCl2 and concentrated HCl, the organic compound A is. All are in the form of esters. First of all, RCOOR. RCOOR is called as esters. Esters undergoes hydrolysis. Condition: 3-degree butyl acetate undergoes hydrolysis, then it gives 3-degree alcohol. 2-degree butyl acetate undergoes hydrolysis, gives 2-degree alcohol. 1-degree butyl acetate undergoes hydrolysis, gives 1-degree butyl alcohol, 1-degree alcohol. So based on that, first of all, here one more condition: C gives white turbidity immediately. This is 3-degree carbon atom is present. This is also 3-degree carbon. Here any 3-degree carbon? Sorry, this is 1. This is also 3-degree. This is 2-degree. So straight away remove fourth option. After that, 3-degree butyl acetate gives 3-degree butyl. This is not butyl. 3-degree carbon atom is present, but this is not 3-degree butyl. Now, this is 3-degree butyl. This is also 3-degree butyl. Compound contains 6 carbons. 1, 2, 3, 4, 5, 6, 7. So remove second option also. So correct answer is first option. The following graph shows the solubility of gas in water as a function of pressure at different temperatures of T1 and T2. What is the ratio of KH? This is based on Henry's law. Okay. At temperature T1, theta is given as 60 degrees. The theta is tan theta. Tan theta, tan 60 degrees value. Tan 60 degrees value is root 3. Second temperature, T2 temperature, the angle is 45 degrees. Tan theta is equals to tan 45 degrees. Tan 45 degrees value is 1. So find out the ratio. Root 3 is to 1. So fourth option is correct. The given graph belongs to 3D series element. Identify the correct statement. Yes, the graph is 3D series graph. Correct. So identify R. R is manganese. This is related to melting point graph. Two beakers X and Y contains CH3COONA. Yes, CH3COONA is strong electrolyte. CH3COOH is a weak electrolyte. Solutions respectively: when the same amount of water is added to both the beakers at the same temperature, which of the following changes in lambda m of solution is correctly observed? What we know, if the electrolyte is strong electrolyte, the lambda m value increases slowly. If the electrolyte is weak electrolyte, lambda m value increases sharply. Fourth option is correct. Which of the following order is incorrect representation of the property indicated by it? Electronegativity correct only. Electron affinity wrong. See, second element electron affinity is more compared with first element. Electron gain enthalpy chlorine is more. Chlorine after, chlorine before, fluorine, fluorine before, bromine. For every 10 degrees rise in temperature, for most of the reactants, the rate gets doubled. For a zero order reaction, the temperature is increased from 35 degrees Celsius to 65 degrees Celsius, the rate of reaction. 35 degrees to 45 degrees, rate of the reaction doubled. 45 to 55 degrees, again doubled. 55 to 65 degrees, again doubled. So 2 into 2 into 2, 8 times of the initial rate. A neutral heteroleptic complex of type mx3y3 shows geometrical isomerism. Yes, mx3y3 shows facial and meridional type of geometrical isomerism. Example, CONH3 taken thrice Cl. Or one more example is CONH3 taken thrice NO2 taken thrice. In the given complex, coordination number of central atom is 6 and its oxidation state +3. Based on IUPAC nomenclature, which of the following statement is correct? So according to this, NH3 is monodentate ligand, Cl3 is also monodentate ligand. No doubt. Fourth statement is correct. Denticity of each x and y is 2, wrong. The charge of y is 0 and charge of x is +1. No, chlorine charge is -1, so wrong. The charge of x and y is 0, wrong. X is 0, y charge is -1. When delta naught less than p, fourth electron enters into T2g orbital of d subshell, resulting T2g4 Eg0. Check it. Delta naught less than p, the ligand is considered as weak ligand field. So weak ligand fields follows Aufbau, Hun's and Pauli's rule. 1, 2, 3, 4. T2G3 Eg1 is the electronic configuration. So statement 1 is wrong. Delta naught less than P, crystal field splitting energy value decreases. Therefore, the electron easily enters into Eg orbital. Yes, crystal field splitting energy decreases. That's the reason electrons are enters into Eg orbital. Assertion false, reason true. The major product formed in the following reaction. Chemical reaction takes place in the presence of bromine sunlight. Not only bromine sunlight, NCS, N-chlorosucinamide, N-bromosucinamide, SOCl2. All these are allylic or benzylic substitution favorable reagents. So here benzyl carbon atom is present. So substitute bromine at benzyl position. First option correct. The IUPAC name of neopentane 2,2 dimethyl propane. A sample of calcium carbonate has the following percentage composition: Ca 40%, carbon 12% and oxygen 48%. If the sample follows the law of constant proportions, the weight of calcium 4 grams of a sample of calcium carbonate from another source will be. It follows law of constant proportions. That's the reason one of the element percentage remains same. So 4 percentage of calcium remains same because it follows law of constant proportions. 4 into 40 by 100, 0, 0. 16 by 10, 1.6 correct answer. Identify X in the following reaction. Given alkyne is given. Alkyne Hg2 plus dilute H2SO4, acidic hydrolysis, add water molecule, follows Markovnikov's rule, add hydrogen atom to unsaturated carbon which contains more number of hydrogens. So C double bond CH2OH. Vinyl alcohol is formed. Vinyl alcohols are participate in tautomerism process. Proton shifted, pi bond migrated. Already in the last video, I clearly explained NCERT exam test number 6. I clearly explained about this mechanism also. C double bond O CH3. Correct answer is 1. Identify correct statements. Formaldehyde means methanol. Methanol is a gas, but here given liquid, so wrong. Acetaldehyde is ethanol. Acetaldehyde is soluble in water. Yes. Acetaldehyde is soluble in water. Check it. It is soluble or not? Yes. Lower member of aldehydes and ketones, methanol, ethanol, miscible with water. Correct. The boiling point of ketones is greater than the corresponding aldehydes. Correct. Lower aldehydes have pungent odor. This is also correct. Fourth option, correct option. The correct order of acidic character. Here NO2 is electron withdrawing group, CH3 electron donating group. Phenol and carboxylic acid. Carboxylic acids are more acidic, phenols are less acidic. So ends with 1. Electron withdrawing group present, acidic nature abnormally increases. Starts with 2, ends with 1. Fourth option. Formaldehyde is more reactive than benzaldehyde towards nucleophilic addition reactions. Correct. Formaldehyde is more volatile than benzaldehyde. This is also correct. Both statement 1 and 2 are correct. Standard enthalpy of formation of H2 gas is 0. H2 gas standard enthalpy of formation is 0. Correct statement. For gaseous diatomic molecules, the enthalpy of atomization is also called bond dissociation enthalpy. Yes, enthalpy of atomization is also called bond dissociation enthalpy for gaseous diatomic molecules. Statement 1, statement 2, both are correct. Enthalpy of formation, H2 gas is 0. After that Cl2 gas value is also 0. After that carbon graphite is also 0. Bromine liquid standard enthalpy of formation value is equals to 0. All these cases are 0. Determine the percentage of X, Y and Z in the above reaction. Ortho 51, meta 47, para 51, meta 47, ortho 2, 51, 47, 2. The bond order and magnetic behavior. Total number of electrons O2 2 minus 18. So bond order value is equals to 1. How is it 1? Already in last video I explained. Calculate the total number of electrons. 14 electrons are there, bond order value 3. 15 electrons, 13 electrons, bond order value 2.5. 16 electrons, 12 electrons, bond order value 2.0. 17 electrons, 11 electrons, bond order value 1.5. 18 electrons, 10 electrons, bond order value is 1.0. So bond order value 1. Even number of electrons, diamagnetic. The glycosidic linkage present in sucrose is between dash and dash. C1 of alpha D glucose and C2 of beta D fructose. C1 alpha D glucose, C2 beta D fructose. Fourth option. Non-essential amino acids among the following. Tyrosine, yes, this is non-essential. Tryptophan, this is essential. Alanine, this is non-essential. Methionine, this is essential. Glutamic acid, non-essential. ACE, third option. Both DNA and RNA contains 4 bases each. Which of the following base is not present in RNA? RNA, thymine. Electronegativity difference between nitrogen and fluorine is greater than the electronegativity difference between nitrogen and hydrogen. Yet the dipole moment of NH3 is greater than NF3. This is because in NH3 orbital dipole and resultant dipole are in the same direction, whereas in NF3 those are in opposite direction. X is non present in cryolite and Y is non-metal present in fluoroapatite. Identify X and Y from the following. Non-metal. Cryolite non-metal is fluorine and fluoroapatite non-metal is phosphorus. Fluorine and phosphorus. First option correct. In the given reaction, the number of H plus ions. Okay. First of all, calculate the N factor value. Oxidation number difference is 5. Left side 1 manganese is there, multiple with 1. N factor value 5. Here N factor value is equals to 2. Exchange the coefficients. Then 2 MnO4 minus plus 5 SO3 2 minus. Remaining atoms you can balance by trial and error method. SO4 2 minus plus H2O. So 5 sulfurs 5 moles of SO4 2 minus, 2 manganese 2 moles of Mn2 plus. How many oxygens? 8 plus 15, 23. Already here 20 oxygens are there, 3 moles of H2O, 6 hydrogens, 6 moles of H plus. So answer is 6. Thank you.